All right. So, this section of notes, we're starting this chapter, this unit, talking about weathering. At least this part of it is. And this is something we've seen before. We've talked a little bit about it, in the past, specifically when we talked about the process for the formation of sedimentary rocks. So, we talked about weathering then. We'll talk a little bit more, just, in a little more depth here. All right, so weathering, just, at its most basic level, it's just breaking of rock. This is not new. Like I said, we've seen this before. So, this is a decent example, even though it's not a natural process with a sledgehammer. It is, breaking rock into smaller pieces. And it's happening all the time. It doesn't take a day off. All of the forces and processes in nature are breaking down rock all the time. Another term that's, used in conjunction with weathering is erosion. So the movement of those rocks, or the movement of those pieces, the sediment, somewhere else. Kind of the key with this is the natural agent. So that's just, another term for, kind of a natural force that moves that from one place to another. So this would not be an example of erosion, because this is, has a dump truck, and those are not natural. There aren't, large herds of dump trucks, roaming the grasslands of the U.S., transporting sediment and rock from one place to the other. So not technically erosion, but the same, eventual gain there, products or materials being moved from one place to another. As far as the different agents that move that material, that rock, that soil, that sediment, water is the biggest one. Be it, rainwater, be it, falling, flowing. So falling water, so we have, both rain and then, waterfall, that type of thing. And flowing water, specifically fast moving water, or faster moving water, it can move an incredible amount of material. If you look at this picture, this river stream appears to be moving pretty quickly. Looking at the surface of the water, it has a lot of white water on it, which means that there's something beneath the surface that's churning this water. And something else with this picture, notice the banks, how it's kind of a V-shaped valley. So as this river has, cut its way down into the earth, it's forming this V-shaped valley, because it's still a fast-moving river that's transporting a lot of material out of there. Wave action. This is something that, with water, water's patient. It doesn't stop. It's relentless. So with wave action, it just keeps happening over and over again. If you look at the shoreline, right by these, I guess, condos, they kind of look like, that shore hasn't always been there. It was further out, but it's been weathered and it's been eroded and kind of eaten away by the ocean, by wave action. And it'll keep going, and eventually, those buildings won't be there. Either they're consumed by the ocean, or they're torn down, or whatever. But and then this next one kind of shows removal of sand, kind of back towards the ocean after it's been washed up. After, I'm guessing, some sort of a storm. So this picture, and like the one before, while living on the coast and right on the shore of the ocean has some benefits, there are also some drawbacks. It can be pretty dangerous. So Not like we have to worry about that here, but you know, ice, and more specifically glaciers. So glaciers are often referred to as a river of ice because it does move, or you know, they flow because they're moving downhill from you know, mountain valleys. They move a lot of material as well. If we think back with the fast-moving water making that V-shaped valley, glaciers tend to make more of a U-shaped valley. So it's a much smoother type of valley as it just plows down these valleys. Anything sticking out is basically just bulldozed out of the way or ground down by the ice and the other rock and sediment that the ice is moving. So it leaves you with a much, kind of like I said, a much smoother U-shaped valley instead of a sharper V-shape. Wind, that's the kind of the second biggest agent of erosion, you know, with water being the first and wind second. So here we have, you know, the picture of some sand dunes, you know, as the sand is, you know, blown around by the wind. Sand is typically the largest size sediment that's moved by wind on a normal basis, not like, you know, 200-mile-an-hour tornado winds that are, you know, moving larger rocks and larger debris and larger sediment, but just normally sand is the biggest piece, biggest size sediment that's going to be moved by wind. Here's an example of some weathering and erosion caused by wind. So you see, you know, it's very rounded, very smooth, because, you know, any sort of sharp edge with wind, weathering and erosion is going to be rounded off. This is a decent example of that. And another one with, you know, wind damage, you know, that also, you know, breaks things down, not just houses and telephone poles, but, you know, the earth as well, and soil. All right, so one of the key points of the unit was mechanical weathering. So mechanical weathering, there's no change in the composition. So we remember back, the composition just being what it's made of, whatever it is. You're not changing that when mechanical weathering takes place. It's not changing what something is made of. It's just changing the size of the piece. That's it. So in this picture, you know, you have a rock and then smaller rocks, then smaller pieces, and that's all it's doing. It's just changing the size. So pretty good example is piece of paper. So I'm just tearing it apart. I haven't changed the paper, like the paper itself. I haven't changed it chemically. I haven't altered what it's made up of. I haven't, you know, changed it other than changing the size of it. So this would be like mechanical weathering, or, you know, hitting a rock with a hammer. You haven't really changed the rock chemically. You're just changing the size of it. So that's kind of the main idea of mechanical weathering. The rock is still the rock. It's just a smaller piece of it. And one of the big things in places where the temperature falls below zero that leads to mechanical weathering is ice wedging, or this frost action. You know, either term, it's all the same thing. This is caused because of the property of water that it expands when it freezes. So if you've ever put a drink into the freezer and maybe you get sidetracked and forget about it, depending on what type of container it's in, you might have a decent mess to clean up in the freezer. If it's in plastic, odds are the plastic's going to expand, so it won't rupture or break. And actually, fun fact, actually, you know, in milk jugs, the sides of the milk jugs where it has like the indentations, that's actually to allow for expansion during freezing. So if it just, if it happens to freeze, those things that are curved in will pop out to allow for the expansion of the water and the milk inside, so it doesn't, burst and rupture and cause a mess. But if it's plastic, it'll probably expand. If it's a can, maybe, but the bottoms of the cans where it curves in, sometimes if that happens, those will pop out. So then like you can't set the thing down, it wobbles around. If it's in glass, that's probably gonna break. Not definitely, but definitely a lot, higher chance of that breaking. But with ice wedging, because of that expansion, when there's a crack in the rock, water gets down into it when the temperature is above freezing. Then when it cools off and the temperature is below freezing, that water freezes and expands a little bit and makes that crack a little bit bigger. Then it heats up during the daytime, water melts, more water comes in there. Nighttime, it gets below freezing, it freezes, expands a little more, and then spreads that crack out even more. And then it's just a process of freezing and thawing and freezing and thawing. And in places where that happens a lot, you get a lot of this. And Indiana is a place where we get a lot of that. So a good example are potholes. So this is kind of the start of a pothole, these big holes in the ground or in the rock in the road. Anytime there's some sort of an imperfection in the surface, like these cracks where water can get down into it, one of the reasons these are such a problem here in Indiana is because our winters are so kind of weird and they're kind of mild. So during the day, it'll warm up above freezing, or especially, if there's, a black surface like a road, it'll get above freezing during the day so water can get down, into these cracks and underneath the blacktop. And then at night it'll freeze. So it'll, raise up that road surface a little bit and it'll, expand those cracks. And then during the day, it'll warm up again. And so you have that freezing and thawing and freezing and thawing. And then, something will, be uneven, and then we'll get a little snow, and then a snow plow will come and hit that piece and break that piece out, and you have cars driving over it, and it just gets worse and worse. So in the springtime in Indiana, potholes are a big problem. And that's why, is because our temperatures are, above and below freezing all the time. It's not like I have an aunt that lives in Montana. They already have a foot of snow and they're expecting more. But there, it's one of those things where, if it gets below freezing, it's pretty much going to be that way for a few months. So you don't have a lot of this freezing and thawing. It just gets cold and stays cold. So they don't have these, issues as much as we do, even though it's a colder area. Wetting and drying. So in areas that have a lot of clay in the soil and they receive a lot of rain and then no rain, it just, dry and just hot, that will crack and break and weather the sediment, and to kind of form that into clay and break it down. Not typically something we have a lot of because we don't really have like rainy season and dry season here in the US so much, but other places in the world, they definitely do. Exfoliation, so where layers peel off. And this is the exact same term and same meaning as what some of you may have heard of exfoliation for, like you exfoliate your skin, you're removing dead layers of skin. It's the same thing. So rock doesn't like to bend, it doesn't like to stretch, it doesn't like to be twisted or bend, anything like that. So when there's heating and cooling going on, when things heat up, they expand. When things cool, they contract. when those processes are taking place, rock is not a good material to go along with that. So if there's a lot of expansion or a lot of contraction, it breaks. So you have some things like this where you can see kind of this outer layer that's cracked and separated itself from the rest of the rock. And it's like I said, it's just the same term, same meaning as exfoliating your skin or whatever. You're just removing layers. It's just that you do it forcibly, and this is because of expansion and contraction and all that. And then we have abrasion. So abrasion, it just means to scratch. If something is abrasive, it scratches, or, it's typically rough, like sandpaper, or where did I put it? It's on the sponge. Have like the sponge side, and then like the scrub side, the Scotch pad side, or whatever. That's an abrasive side. Or like the episode of SpongeBob where he's tired of people taking advantage of him, so he decides to get an abrasive side. So on his back, he has like one of those Scotch pads, so he's a little tougher, has that abrasive side. But abrasion, wind blows pieces of sand, and over time, those little pieces of sand colliding with rock and with other material will eventually wear it away. It weathers it and erodes that material away. So that's how we get these, natural arches and things like that. Depending on what the rock is, what it's held together with. Some are harder than others, so that's why some places, weather more quickly than others. But that's abrasion. And then plants and animals. So this is kind of a weird picture. This is actually a tree. So this is kind of one of those, we've seen them, I'm sure we've all seen them in sidewalks where they have kind of a cutout where they have a tree growing. And this is definitely overgrown that space. So the roots are, breaking the curb apart. And plants and trees, do break, rocks apart as, the roots grow down into cracks and crevices. This is also the cause for it. Maybe if you've seen like a sidewalk, and then the sidewalk either just pushes up for no reason, or maybe there's a sidewalk and it, like one piece is pushed up. A lot of times the cause for that is because when they poured the sidewalk, there was a tree root underneath it. And then as that tree root's growing, it's getting bigger and bigger, and it pushes all the material above it up because it's growing. So it's going to push up, the sidewalk or one piece or something like that. So if you've ever seen that, or maybe not, but that's typically the cause for something like that. But they, definitely can break apart rocks. Does anyone have any questions, or are there any slides that I need to go back to?